Hello everyone, this is Miss McMunn. This will be for Algebra 1 third block. It will be about systems of equations. All right, so with systems of equations, it's more than one equation. And so how we used to graph just one equation and see the slope of it and the y-intercept, you can do that with more than one equation, and then you can see where they meet or cross. And so with systems of equations, they're really applicable in the real world. So that's why I wanted to make sure that we understand the situations that go along with systems of equations. And so I've got a system of equation on the screen. It is, which restaurant would you eat at? Now, I just made up these prices, but here's the situation. Golden Corral charges $11 for a buffet plus $1 for each drink. Western Sizzlin charges $9 for a buffet plus $2 for each drink. Which restaurant has the best deal? So you can actually use where you've got two different situations of prices or anything with numbers, and you can build a system of equations. And then you can graph them, see where they cross, see where they're, the same, and then analyze it from there. So I'm just going to walk through this example just so that you can see how to pull the information from the problem. So the first thing you need to do is write two equations to represent the two restaurants. So my first equation will be for Golden Corral. And if we look at Golden Corral, you got $11 for a buffet, right? So you can say that's going to be $11 for every buffet that's on your receipt. And you can just say 11B. Like B can be the variable for buffet, and then 11 goes beside it because that's how much one buffet costs. So you've got 11 buffet for every buffet, so 11B. And then we have to add in the drink price, which is just $1 for each drink. So we could just do 1D for one drink, $1 every drink. But we don't necessarily have to put the 1 there. We can just put a drink, and that's an understood 1 in front of there. So 11B plus D is going to equal your cost from Golden Corral. Okay, so that right there is an equation. 11B plus D equals your cost. You can even put C for cost if you don't want to spell the whole thing out. Okay, so then for Western Sizzlin, we've got to make the equation for that one. And that one says $9 for a buffet. So instead of 11B here, we're going to have, what do you think, Cheyenne?
9B.
Very good, very good. And then we have to add in those drinks. And instead of 1B, Western Sizzlin should be what?
2D.
Yes, very good, 2D. I said D, my bad. So 2D. And when you add those two things together, that is your cost for that one. So which restaurant has the best deal? Well, you can actually figure that out by looking at the graph of these equations. Now, we chose a B and a D. We very well could have just done 11x plus y. And then in Western Sizzlin, we very well could have done 9x plus y.
Okay.
Cheyenne, or 2y. Cheyenne, which one do you think just already would be the better deal?
Half of me says that Golden Corral would have the best deal, but more of me says that Western Sizzlin would have the best deal because you're paying less for the buffet but paying just a little more for the drinks, while at Golden Corral you're paying more for the buffet and less for the drinks. I feel like $9 for a buffet would be the good deal. $2 for a drink doesn't sound bad. A little overpriced, but doesn't sound bad.
I agree. I agree. They compensate with their low buffet price by charging you more for a drink. Um, so if you drink water, you would do better there if they didn't charge you for the water. But you know, they have to make money somehow, I guess. All right. So now let's predict if these equations will be linear or nonlinear. So the ones that we created here, do you think these are linear? That they will create a line when we graph them?
I don't think so.
You don't think so? Well, so the thing about being linear is that your variable has to have an exponent of 1. Or it cannot have like x squared or x cubed or x to the 4th power. It has to have a 1 there or nothing beside it. And since we have that x and this x that do not have an exponent other than 1, it actually will end up being linear. So if we were asked this question, we would say yes, because the variables have exponents of what?
1x.
Of 1, yes. The exponents are 1. All right. Now, if they are linear, will the lines point upward or downward? So do you think they'll have that positive slope, or do you think they'll have that negative slope?
Positive slope.
You know, we both be positive. Why do you think that?
Because they both have plus, no negative numbers. They're not taken away from anything, and they're not ending up as like negatives.
Very good. So as you like eat more or have more people there, the higher the price will go. So you're exactly right. It will go positive. Very, very good. So we're going to say upward because the slope will be going up. All right. And then it says to graph the system of equations. So I'm going to go to Desmos and we're going to graph this. We're going to use the X and Y version just because Desmos likes X's and Y's better. But you can use whatever letters you want to when you're building a system of equations. All right, so we've got 11x plus y. Okay, there's 1. It's giving me a little, so once an equal sign, so we're going to have to set this equal to 0 just for it to graph it. And then we'll have 9x plus 2y. Let's just see what happens. Okay. Cheyenne, what do you think I'm concerned about here looking at this graph?
That the blue line is a little bit further from the red line.
Yes, and so that's because the restaurant is kind of like increasing in money. This one would be slower than the red line. The red line would be faster. But what did we talk about with the slope? What were we expecting to happen?
Them to intercept.
They will intercept. What about what we were talking about? Let's see, what number was that? Number 3. Do you think the lines will be pointing upward or downward? We thought that they would be going up. But the graph, for some reason, is not. So what do you think the issue is here?
The different pricings and not having the direct costs.
Say that again?
Costs. Not having equal costs.
Okay.
And then both being 0.
maybe. What happens with standard form of equations that we have this in right here, the x plus y, is you're technically supposed to have it where the x is all by itself, where there's not a coefficient in front of it. So I'm just going to add something here and see if it fixes it. I'm going to take this away. No, that's going to be the same line. Might be the plus 0 that's making problems. Let me try something different. Okay. If we were to solve this right here and put it into slope-intercept form, Cheyenne, we would get a negative slope because we'd be moving this 9x over. So let's just use a different variable for cost. Equals C. Let's see if that works. Okay, so if the cost is $10, it went that way. That doesn't help any. Okay. I still agree with you, though, that the slope should be going up like this. Should be going up because as you buy something, your price will go up with the more people for your buffet. So I'm going to look more into that, and I'll add it to the end of this video after we get off. So check back the video later for the last like 5 minutes to figure that part out. Not really sure why Desmos is being weird. But I will say that even if you have two equations like this, where those cross, what you noticed in the very beginning, that is their point of intersection, or basically like where they both would work. So like if there were 0 buffets and 0 drinks, then the cost would be the same. It would be 0. And that's what that point right there is, the 0, 0. It's basically saying if you have 0 of both things, the cost is going to be exactly the same. Does that make sense?
Yeah.
Okay. So the point of the intersection is just the point that works in both equations. All right. So to verify that the intersection point works for both of them, if we go back up here and we plug in a 0 here for the x and plug a 0 for the y, what are we going to get out if we do 11 times 0 plus 0?
0.
Exactly.
Wait, yeah.
Exactly. And then it should be the same way up here, so or down here. You plug in a 0 for this x and y, what are you going to get out?
0.
Exactly. So let's, yes, it does. Yes. 0, 0 works for both equations. All right. So which restaurant would you go to? And why?
I thought about it in my head just now. Southern Sizzlin', you would end up spending about $11 at that restaurant, while you would be spending about 12 at Golden Corral. I feel like you save money going to Western Sizzlin'. It's not a lot of money, but you'd be saving money.
That makes sense. It does.
Yeah.
Okay, so I'm going to try one more thing over here before we move on to the next part. I'm just going to try the buffet cost. So we're going to say y equals 11x for Golden Corral. We're not going to add in any of the drinks, okay? And then down here, it would be y equals, how much was Western Sizzling?
Like all together?
No, just the buffet.
Oh, 9.
Very good. Okay. So if we just look at the buffet, then we can look at the difference of these two. It's just a slight difference because it's $2 different. But still they have the same point of intersection at 0, 0 is where they will be the same.
Yeah.
Yep. All right. So with systems of equations, the most important part is that you can take a real world situation and then be able to write equations like this to represent them. Okay. So what I had planned was I have a little Kahoot where it's a couple of different situations, and you get to choose which one you think is, like which system of equations goes with the set. And I think I'm going to actually play too.
Okay.
So are you able to play Kahoot?
Yeah, I'm able to play Kahoot.
Okay. Let me just, there we go. So I'm going to
menu.
play as well. What did you say, Cheyenne?
I can exit the Zoom menu.
Okay.
Might figure out how to do that. There we go. It is escape.
I'll assign this in Google Classroom for later too, for the people that didn't get to participate during the live one. I don't think I'm going to put the two-step on because I don't think you'll try to crash our game. So we'll just do the regular one where it's just a pin in your name. So all this week, all we're going to focus on is like looking at the situation and writing out the system of equations that represent it. Because I feel like that part is the most applicable to the real world at this time. I'm working on it. My phone is being super slow. My internet went out for a little while, but it is back on, thankfully.
Yeah, our internet was being funky too.
It doesn't like storms. Okay, I'm in. All right. Ready? Okay. So, what are the two items that in this situation they are buying? So, let's see. The situation says Nicole and Ming each improved their yards by planting hostas and geraniums. Those are flowers. They bought their supplies from the same store. Nicole spent $220 on 11 hostas and 12 geraniums. Ming spent $41 on one hosta and 3 geraniums. What is the cost of one hosta and the cost of one geranium? Okay, so I'm gonna turn this. Okay, there's the music. Okay, so what are they buying? I think I chose one. You got 3 seconds to choose. Oh, you got it right. Very good. See, I was a little confused because I saw hostas and geraniums here. Oh, I thought I read a different type of plant. Oh my goodness. Okay, so yes, you are correct. The hostas and geraniums are what they are buying. And so that means when we set up our system of equations, for Ming, she's going to have an equation with hostas and geraniums. And then Nicole's going to have another equation with geraniums and hostas. What variable do you think you would use for hostas?
11H and 12G.
Yes, that's going to be for Nicole. And what do you think Ming's will be?
1H and 3G.
Very good, very good. All right, so you're going to get the next one quick. It's the same situation. You just got to pick which one of those represents what you just said. And instead of H and G, they used X and Y. Okay.
Oh, I got the numbers wrong.
Alrighty, so on this one, the green, it's the exact same numbers, but what's the difference in the green and the red?
It's negatives. I didn't see the subtraction signs.
Yep, so whenever you're adding something for a cost, you use the plus sign. If it was like saying that you were taking it away, then you could use the minus. But you're combining it for a total cost, so it has to be plus. All right, we're neck and neck. All right, what are the 2 items being bought here? So it says Castell and Pranav each improved their yards by planting rose bushes and ivy. They bought their supplies from the same store. Castell spent $69 on 3 rose bushes and 12 pots of ivy. Pranav spent $54 on 6 rose bushes and 3 pots of ivy. Find the cost of each rose bush and cost of 1 pot of ivy. All right, so I'm not going to get this one wrong like I did before. It's not just plants. I don't think it's just roses. And then Castell and Pranav, those are the people's names. So what they're buying is rosebush. Yes. Okay, yay, yes. All right. So we can actually take those things that we were just thinking about, the rose bushes and ivy, and put it into an equation now.
Yeah.
So instead of R and I, they're using X and Y. We got to find the one where they're adding them together, and we got to make sure that the ending is the cost for the whole thing. So 3X. I think it's the green one. Let's see. Is that what you chose? Very good. You're so fast. All right.
Makes a lot of sense.
So what about this one? The 2 objects being sold here. Scott School is selling tickets to the annual talent show. On the first day of the ticket sales, the school sold 7 senior citizen tickets and 12 child tickets for a total of $160. The school took in $62 on the second day by selling 10 senior citizen tickets and 2 child tickets. Find the price of senior citizen ticket and the price of a child ticket. Okay, so instead of 2 different people's equations this time, it's going to be an equation for the first day and then an equation for the second day. But they're still selling just tickets, but it's not just student tickets. They've got
students and senior citizen tickets.
Yep, senior citizen. And I think it might be child though, because it says,
Well, I said child. My student
yes,
thinks
I think it's the, yes, very good, very good. All right, now we've got to take that information and put it into equations to make a system of equations. So the first day equaled 160, so we know that. And the second day equaled 62. We know we need addition signs in both of them to combine. And we know that for the first one, the X, the senior citizen, it was seven of them. And then for the 12, that was your child ticket. So they're using Y for child. So I believe it's this blue one.
blue one.
Is that what you picked?
Yeah.
Awesome. Very good.
I got a streak of 4.
Listen, we are neck and neck. You're gonna beat me. All right. What are the 2 items being bought here? So you're at the movies and you want some snacks. The combo is $8 and a candy is $5. If you buy a total of 6 snacks and spend $45, how many of each snack did you buy? Okay, so this one, you're buying the combo and the candy. Do you think that this is a system of equations here?
Yeah, definitely a system.
Okay, why do you think so?
You bought a lot of this like snacks, and each snack cost this certain amount, and the combos you also bought, which were also a certain amount.
Right.
So it's gonna be a system of things. Considering I spent $45 on snacks and combos.
Okay. So I do agree that they're selling combos and candy. All right, they're selling 2 things. But for it to be a system of equations, you need 2 equations, not just 2 things that are being sold. And so, like here, it was just talking about one person buying those 2 things. So it would be one equation. For it to be a system of equations, it would be like you and then your friend. And it would be 2 different equations. So now we are going to find the equations. Now, I was just saying, there's really not 2 equations here. I don't think there's 2 equations at all. So, is this a trick question? I see what they've done. They didn't do 2 different people this time, but they did 2 different situations. And so sometimes it can be this way. So do you see how they've got like the prices 8 and 5, and then the cost together is 45?
Yeah.
Okay, so that one is for sure going together because they both have the dollar signs. So like 8x plus 5y equals 45. That one for sure goes in there. But then it tells you that you buy a total of 6 snacks.
Oh, I see now.
So they're kind of saying, like, if you add up however many X's and Y's that you bought, it should equal 6. So instead of 2 different people's costs, they used your cost and then how many you bought to create a system.
I hope I chose the right one, but I understood what you said.
Okay.
Yes.
Very good. Very good. So this second, the blue one was a trick because they were trying to get you to put the 8 and the 5, the money part, with the 6 snacks. But the 8 and the 5 are money, so that's got to go with the money total.
Yeah.
Okay.
6 is just how much you bought of that.
Exactly. Very good. All right. So, oh my gosh, we were how many points apart? 5, 6. Not like 12. Wow. Wow. Very good job, Cheyenne. I'm very proud of you.
Thank you.
You were this close to surpassing the teacher here, so I'm very proud of you.
This is really easy to understand.
Good. All this week, that's what we're going to work on is just you looking at those types of situations and then building your system of equations. Next week we might add in like putting them in Desmos and finding out where they cross and finding the solution to the system. But this week I just want you to see how it applies to the real world and then be able to build those equations based off of the world.
Okay.
Okay. Do you have any questions about systems of equations?
No, this is stuff I understand.
Okay, good deal. So on Wednesday, I'll post that vocabulary assignment about it. And then on Friday, there'll be a practice set on quizzes about it. And it'll be exactly what we just did in this Kahoot, pretty much.
That's great. I should be good this week.
All righty. Well, if you need anything, please let me know. I hope that y'all stay safe and healthy.
We will definitely try.
All right. Bye, Cheyenne.
Bye, Miss McMunn.
So I did some research about the problem that Cheyenne and I ran into earlier, and this is what I found. So basically, when you graph with Desmos, it only supports two variables, x and y. You can't have more than that in your graph, or else it just kind of freaks out a little bit. So what we can do to fix this is, for this situation, we can say, okay, the cost for every person if they eat a buffet and a drink for Golden Corral would be $12 for every person, so that would be your X. And then that would equal your cost, which would be your Y here. And then for Western Sizzlin, we could do the same thing, and that one is $9 and $2. So that one would be 11x, $11 for every person would equal your cost Y. So for this situation, you can plug this into Desmos and see that it is what we expected. They both have positive slopes because every person makes the price go up. So if you notice, they look almost like the same line, and it almost is, but it's off. The slope is off by $1. So it's a little bit of a difference. If you zoom in, you can start seeing that they're actually not the same line. They're a little bit apart from each other. And then it still has the same point of intersection. Basically, if you have 0 people, it will cost $0, and that's where the two equations meet. And in a systems of equation, that's what you're looking for, is where the two lines cross. So I just wanted to share that. And later on, we do have to graph these to solve. It might not be what you think, as we saw earlier, it was a negative slope and we thought it would be positive. And that has to deal with it being a system of equations and more than one variable. And there's a lot of components that you have to think about. And it's what we're going to get into next week. All this week that we're going to focus on is taking the situation, kind of like this right here, and then writing the equations like we did here and in the Kahoot. So next week we'll talk more about graphing them and putting them in and see where their meeting point is, or the solution to that system. But right now we're just going to deal with real world situations and writing the equations out. So I will post this Kahoot along with this video, and make sure that you play it to practice what we did today in our instructional session. And then Wednesday you'll have a vocabulary assignment, and Friday you'll have more practice on this same topic. So I hope you guys have a wonderful day. I hope that you're staying safe and well. And let me know if you need anything, please. I'm here to help with your math, and I don't want to add any burdens to you, but I do want you to continue learning. So if I can help in any way, please let me know. Bye.